All right. Well, I guess I'll kick things off tonight. Welcome everyone to the March 2019 meeting of the Australia and New Zealand PowerShell user group. Tonight we've got Fred presenting. So for those unfamiliar, we've got a couple of links there to keep in touch with us. We've got a website up on GitHub pages where I'm trying to list all of our previous meetings and upcoming dates and whatnot, and various contact links and all that. So if you only remember one, it's that github.io link. We're also on Twitter and of course on Meetup, which is where all of the actual event details go. So of course this is an Australia New Zealand user group. Over in Australia we've got Adam and Shah, and I'm Josh here in New Zealand. And feel free to reach out to any of us, especially if you've got any topics you want to present or any ideas or requests, anything like that. And I hit the wrong button. So yeah, tonight we've got Fred talking about his PSFramework module, and yeah, it's something that I've been meaning to look into myself for ages. So Fred, I imagine you probably want to get to work. So if you want to jump in, go for it.
Well, let's see what I can make that happen. Yeah, thank you, Ben.
Stop presenting. There we go.
Let's see. You should. Not yet. Yes, I know people will be visible if I will see it if I share it. That's kind of the point. I love the security prompts. All right, you should be seeing something remotely PowerPoint here.
Yep, there we go. It's just popped up for us.
All right, welcome to my introduction presentation on the PSFramework module. Thank you for joining me today. All right, my project really has a motto. I'm trying to give people the power to do what they want to do. It's like the project dedicated to empowering your PowerShell scripting. It's kind of a cloudy, untouchable, imprecise marketing slogan. So what's really behind it? I've seen so many times, and I've done it myself, that people write a command like, let's call it write log. Like logging, there's so many common scripting tasks we use. Logging is one of the most common and most graspable, which is why I always use it as an example, that we need to do in order for our main work and project to really work. But it doesn't drive the business value. It's just an extra we need for security, for code maintenance reasons. And my project is really trying to take away all of this extra overhead so that users can focus on, well, what drives the business value of their code, really. That's what it's all about. I've got a project website, PSFramework.org, which contains all the things. Now, one of the less fortuitous naming issues I've encountered, I've got a bit of a naming overlap, and that is the PowerShell framework project is not the PS framework. The PS framework is part of the PowerShell framework project. It also has additional tools, specifically coding tools, and for interactive console productivity. And recent addition, a mail daemon that handles the mailing problems that scripting is generally bound with, specifically things like if the mail service is down at the very moment that you're trying to send mail, your message is gone, lost. So any kind of notification system that you have in your scripts by default, if the mail service is not quite available at the moment, you're out of luck. But we are not going to be focusing on the PS framework itself, the module, for this presentation. Specifically, we'll be looking into configuration, how it can handle options, like an options menu, or how it can manage all kinds of configuration settings in different kind of configuration scenarios. It has a message and logging handling system, which is one of its core features, and we'll be going through it quite extensively. We have tab completion, tab expansion, which makes it a lot easier and cheaper to deploy custom tab completion, dynamic tab completion. We have background tasks, we have parameter classes, validation attributes, various kinds of handling how the code executes, and so many other components that can happen during your day, and that you'd have to write your own tooling usually for that. Now, this is also, you can see on the screen, one of the very problems people have with the PS framework, because you're basically buying into a huge grab of tools, and where to start? How can it happen? How can it help me? And this is what we are going to be looking into today. First of all, yes, I want to kill the session. Okay, let's start with the configuration system. When you run get psfconfig, you get a huge load of settings, all kinds of options. Think of it like this: if you start Outlook and have an options menu that controls how your module behaves. This is exactly the same thing. I've got a setting, for example, for developer mode, and it's set to false, and we have got a description of what it means, which means we not only do we avoid things like global variables we expect the user to define, which really are bad from a discoverability perspective. We also have additional aspects like validation that comes with it, and various other important pieces. So let's take a look at one specific one I defined obviously for this session. And we can just arbitrarily create new settings. And by using export psfconfig, we can straight export them to a configuration file and import it again. So let's take a look at how that looks. This is a, well, plain JSON file. There is a new format out, but yet to be documented. I'm still working on the documentation part for that. That will make this even easier from a JSON file perspective, more readable. But short of that, we can now start a new console. And as you can see, there's quite a few other configuration import commands. Yes, thank you, Fred. Talking about making it convenient for users. Okay, we just imported the same settings we defined here into the other console. And demo module, yeah. Grabbing the correct configuration settings obviously helps with that, if getting results. Okay. As you can see, we can easily store and transmit information. This uses under the hood either JSON serialization or the default export and import CLI XML commands. So we can store and persist and pass through configuration any kind of object PowerShell knows. Now, this is all nice and nifty, but frankly, if we have to run import psfconfig, that's not quite convenient. So what the configuration system does is when the PSFramework module loads, it will look at certain locations. Whether there's a configuration file, or if you're on a Windows machine, and yes, it is fully Linux compatible, it's a core compatible module. If you're running it on Windows, it will also look in the registry for certain locations, and if there is configuration setting persisted there, it will import it. Specifically, we use register PSFconfig to register a setting. So we have the setting 1 defined as 24, as we could see here. So let's register it. And if we now start a new console, we can see setting 1 that was registered is now automatically available. I did not need to run any kind of import or export. It is just there. Register PSFconfig by default registers the setting to the current user registry on Windows or to the user profile config file on a non-Windows machine. That's the easiest way. For example, a user could prefer to remember certain settings, like, well, what indent preference he has, or what other options you might want to persist. Since it supports registry values, this also means you can deploy settings for your modules using group policy, or SCCM, or Ansible, or Puppet. Depending on how you want to deploy these files, you can automatically manage and deploy settings, and thus do background updates without having to update your code. For example, if you've got dozens or hundreds of servers with scripts that might send an email, send notification emails, you could use this to update and publish your you could update and publish your mail server using configuration, and that would allow you to update your task configuration on hundreds of machines without having to go back and fix every single script just because you had a mail server migration. Sounds like a benefit for me. All right. From another perspective, let's move on to the logging system. The logging system is generally the most impressive one, but since virtually everything in the PowerShell framework builds on the configuration, I always start on the configuration part, because all the messaging system and all the message system and other components simply consume it, are controlled by it. There's so many options that are available through the configuration system. So I can talk about it on slides, but in action it's always easiest. Back in the day, I had a bad habit, a really, really bad habit. I was using this particular command, and I was using it a lot. In my opinion, this is one of the most dangerous commands in all of PowerShell. Why? It teaches a bad habit. One of the main things we often do, especially as beginners, is when we debug things. Well, originally we used to use write host for that. Just write things to screen and see where the red stuff starts happening. Well, yeah. Then somebody came along and told them, when you ever use write host, God kills a puppy. So we need to change. We can't go killing puppies. We can't just do that. So after some moving and other pain points, like using write output instead for progress messages, people settled on using write verbose. But what happens when we use write verbose? Well, nothing unless we specify -verbose. And that taught us the habit for debugging. Imagine you run a script and it breaks. What's going to be your next step? You're going to run it again and break things again, only this time with -verbose. So basically we got into the habit of, running things again and breaking things again. That's what he taught us. And while that's not quite harmful on a get command, I once got a call from a customer asking me why I kept restarting his terminal server. 8 times. And I kept wondering why I always kept getting different error messages on each run. So we have no idea whether this will. We have no idea whether our execution will take the same path the next time. We are now in an unknown state because the code had an unexpected exception. We're trying to debug this, and well, if you try it again, no guarantees it will work out that way. So all you really need to do to get started with the PSFramework logging system is replace all your write variables with write PSFmessage. Now, we have forensics. The message was not written to screen, but we have access to it after the fact in memory. What's even more fun is, I hope you know push_rs_job, but basically what it does is it is jobs in background run spaces. So if we now start running something in the background, we can still access the message. So the first real feature in this is you can get live insight into what is happening in your background tasks. In whatever you push into the background and any workloads you parallelize, by default you would not get any message even with -verbose. With this you can get a live access to that. And if we take a look at this, you can see we've got different run space IDs, so we can group by what's happening at any given time, and we have lots of meta information, like the timestamp it was written at, or the level we wrote it to, which is by default variables, but we can change that. We'll get to that right. You could add tags. It picks up the function and module it was written from, or even the person that called it, the full call stack. We get lots of meta information that help us debug. So, not everything is supposed to be hidden from the user by default. So we can switch the level and thus increase and decrease the visibility of the command. Including warnings. All right. How would that look in a command? For example, let's say we just have a simple command accepting computer names from the pipeline and then doing things with them. And at that point, we just write messages throughout the entire command lifecycle. Let's load it. I think we might need a little bit more screen space for this. And just run the names. Okay, it first got started on the object, then it executed the line by line, and we used debug, but we were not interrupted. By default, the PSFramework write PSFmessage command will not interrupt when you specify debug. Also, when using debug, we get the line numbers for easier breakpoints. What it also shows is that there is no parallelism involved in pipelines, which is a side benefit of this demonstration, because it first ran begin, then it ran one object until it ran through, and then the next and the next. We can highlight this a bit more by running it through each pipeline if we were specifying that into more details. I ran a full show on how the pipeline behavior on the last PowerShell Summit. By now, the videos were actually published to YouTube. I'll have to pick up the specific link. Sorry, I did not prepare that. But we can now send through several servers through the pipeline. And let's take a look at how does all those things look in logs. I was talking about logs, but so far we only have taken a look at the in-memory with get PSFmessage. Thank you. I love this easy scrolling thing. First of all, the configuration setting. All the logging configuration, including the path where it's logged to, is in the configuration system. And if we open that, you can see we've got some logs in here. Quite a few very recently. This is the most recent one. Let's take a look. Okay. We have a rather verbose log with all the content we need. It's a CSV format. We can just ingest it using import CSV and start using it. So this happens automatically. However, if you take a look at this folder, this does not go back all that far. The oldest entry is from March 5th. What's happening here is, this is the automatic debug log. Everything that is logged under the current user is dumped in here, which would be a good way to, gather huge log files. So it has an automatic log rotate for about 1 week. So after 1 week, it will start killing the oldest message. Take a look at that. Specifically, this is a configuration setting, max log file age. You can, of course, given that we have a log path as configuration setting, deploy a central logging directory for this. And it has other limitations. For example, the maximum folder size is 100 megabytes. So even if you write massive amounts of logs, the debug log will automatically log rotate. Now I'm talking about debug log. Does that? I'm talking about something log. So is there another something? There is. The logging system is actually plugin based. So you can extend it if you target of your choice. You can log to a SQL database. You could log to event log. You could log wherever, and enable it simply by enabling the specific logging provider. So let's go about that. We need to wait on this one. Now we just enabled a log specific to this current process, or like a dedicated log for a given script file rather than having one for everything a user does. And now we've got a log CSV in here, and if we grab that, it just picked up the last message I just wrote. There it is, yes. What this also means is you can move to this logging system now, and if you've got like a SIEM solution coming up next year, you could update your logging targets without having to go back and fix your scripts, because you can deploy it using configuration. For example, it comes out of the box with support for Graylog. So if you've got a Graylog server, or you get one later on, you could just enable it, and all your scripts will, at that time, instantly move to logging there. And if you take a look at this log, the last message written, yes, a different console. This is the one. Here, we just wrote that message to the debug log as well. What this means is that the logging plugins can coexist. You can have multiple logging targets enabled at the same time, and it will just work. It will work just fine. So you can have a smooth cutoff to a new logging system without having to disable your old one. So you can test it in your production environment without hurting current execution. Now, this is not quite everything by now. for the whole thing. Because, all these messages we've written right now were pretty much in English. However, if you have to deal with multiple languages, that can be a problem. So, for the user at least. So let's take a look at these two files. What we can do is we can load language files with keys and messages associated with them. So let's go ahead and do that. Imported both languages. And rather than using the message parameter, we can now use the string parameter to load the message in question. And it instantly picked up the English one and inserted it. The language we currently use is configured. It is automatically picked up by the console host, unless the user overrides it. So let's... Oh, wait a sec. Why does this... I was actually already in English, so let's try to do this again. English, German. Okay, it appears I have a bug, so I can't show that off, sorry. I'll need to prioritize fixing that one. It should not have happened. Or did I load the wrong file? Yeah, the demo gods are not merciful. Damn it. Okay, let's move on and not try to fix a broken ship. Here, let's go to custom tab completion. Many people use dynamic parameters to calculate a dynamic validate set and generate tab completion from that. But dynamic parameters have so many disadvantages. Really, please don't do it. Whatever you do, please don't use dynamic parameters for custom tab completion. If you do that, well, bad things happen, including incurring the wrath of Fred. You've been warned. Thank you, Josh, for the support. All right. First of all, we need a command to complete for. So let's grab one of my most favorite commands. I'm assuming there is nobody underage in the audience. So we don't have any tab completion for the command at the moment, of course. So let's drink a beer. Looks just fine. But it's so easy to confuse, and let's be honest, this is not going to work well for us. We need, obviously, tab completion for this. So, the system is really simple. First, we need a script block that is going to produce the values we want to complete. This could be an Active Directory query. It could be a static list. So if you want a static list, you could go with static validate set. You could look up an Active Directory. You could ask your Hyper-V hosts. You could ask PowerShell, whatever. Wherever you get the data from, it needs to produce the data somehow. And you give it a name. And then you assign it the name of the script block to the parameter of the command you want to complete for. Yep, absolutely, Josh, absolutely. I haven't found one yet, but if I might just set one up myself just for the giggles. All right, first of all, we define the script block, and then we register it, and that's all. We now have custom tab completion. This is not going to work well, but I advise against drinking a pitcher of whiskey. Now, this is all nifty. It's pretty awesome, actually, in my opinion, but it's not going to work. It's not nice, but we can't really drink a pitcher of whiskey. What we actually need is tap completion now for the unit, and not every kind of alcoholic beverage should be served in the same, kind of glass, kind of container. So we need to react to another parameter that was already bound. Not a problem, we can do that. By creating a new script block that accesses the current, like a PS-bound parameter object from what's currently available by using fake-bound parameter and checks for the type parameter. And that allows us to create a highly authentic drinking experience. And we need to again assign it. So now we can go for a beer and get the full German drinking experience. While a proper Viking will obviously drink his meat from a horn. Okay. Now, this is all well, but there's more to it, and quite useful more to it for some circumstances. So let's grab a somewhat more sober command and register a script block that is going to take some time to execute. Now here's the thing, when I have a static list, when I do a local query, it's usually rather fast. But if we now go ahead and try to complete type, I just hit Control spacebar. If we do a remote command, I fake that by using start sleep here, obviously. But if we do that, we have to wait. This is not a perfect user experience. And especially, we have to wait again. And again, and again, and again. This is not quite well. Also, I may admittedly want to create some values for that first. Tab completion no longer fails. But yeah, still, it takes a lot. So, what can we do about that? What we have here is a parameter called cache duration that will control how long the current values are valid. So let's go ahead and tell the system the values are valid for 30 seconds. So now it retrieves the data. And now it was instant. We didn't have to wait. I mean, think about it. You provide tab completion for the domain controllers in your domain. You don't need to refresh that data on every single request, do you? They're not going to change that fast. So this allows us to cut down on it, but after 30 seconds now, well, we'll have to wait again. Yes, so we now have, well, cut down the waiting time to a certain interval that we can pick in a sane manner, but wouldn't it be a lot more convenient if we could push all of the refreshing into the background? All right, thank you, Ben, for bringing that up. This is significant danger. If you're going to work with cached results and filters, obviously, if you're respecting input filter from some other parameter, for example, and use caching, and it will apply the same limitations to all requests, even if a subsequent request within the cache duration would have separate filters. For example, above, we are filtering by the type parameter on what class to provide. If you had caching for that, why should I talk about it if I can show it? This is a lot more convenient. So now let's go with that again and give this a cache duration of 1 minute. So now we get very German measurements. So far, so nice. And we still get the beer logic going on here. Because the cache does not differentiate on the logic that is executed within the script block. It has no way to know it should refresh. So keep that in mind then, if you're going to be including AED user filters, the filters will stick around. All right, let's see what we can do about refreshing the data in the background to await we ever have to wait, rather than every 30 seconds, every 2 minutes, every whatever. And that's where PowerShell tasks come in, because the PowerShell framework has a task scheduler that allows you to schedule script blocks to run in the background. So let's go ahead and tell it to every 15 seconds to refresh the water type. And that would basically be it. What do I use this for frequently? Well, expensive tab completion calculations. You may want to worry about hammering your domain controllers every 15 seconds for a full list of all users. Your AD admins might not be amused. So what I like to do is I like to offload certain expensive calculations from module import, because it would slow down the user experience, and that's what one of the main uses I use it for. Specifically, things like cleaning up temporary folders, things like that. So I give it a name, I run the script block, which basically is just kill all demo module stuff from a temp folder in this instance. I tell it to run once only, to give it a delay of 1 minute in order to avoid a task spike. And I tell it it's not important for me, it's a low priority task. I don't care if it takes 2 minutes instead. What's happening here is, in the background, there is a single run space executing all tasks that we queue. So if we give it 10 tasks, they will not be run in parallel at this specific time. They will be queued, and the most important one will be run first. Slav, please don't go ahead and ruin my argument here. There are cases where you need to keep track of that. But yes, we can have it run once only, and they will all run in parallel. So the task engine is not a guarantee for having exactly this interval. It's not a precision piece. It's something you can give a script block and not have to care about it anymore. And you can reset it if you want it more than once, which is cool. Okay, let's move on to the next one. We're kind of pressed for time. Parameter classes. Parameter classes, the PowerShell framework not only offers commands that do things, it also has a pretty large C# library, and it offers some interesting types, data types, that can make your work easier. Specifically, parameter classes. It introduces the PSFcomputer parameter class that performs input interpretation for you. So if you ask rather for a computer name string, you could ask for a PSFcomputer, and it does all the parsing for you. For example, 01 works out well. It is not localhost. It is a name. Works just fine. Now this is a pretty bad computer, so we are not going to accept them. There is no white space in a computer name. We can't do that. If, however, you really want to offer a SQL Server connection string, that's okay. very obviously points at a computer. So we accept that. It picked up the server 1. At the same time, we also are very happy to accept any kind of DNS resolutions, or even the dot for the local host. Now, there is one very, very important aspect to this, and that's this property, input object. It provides a unified name that is always correctly resolved. You can rely on that. So if all you need is a name, use computer name. However, the input object property means the original user input is preserved. So the user could provide a PS session. I can't show that on a private device, unfortunately. But you can pass through remoting sessions and reuse them without having to destroy them. And when you use that the resulting object, the PSF computer object, on anything that expects a string, it will work. So let's define the command. And see what happens here. It correctly inserted the name and interpreted it. So all you need to do in order to have huge input object interpretation, which by the way also includes AD computer objects, as you can totally pipe Active Directory computer objects to this command. It will understand them correctly. All you need to do is replace string with PSF computer and you're done with the migration. At the same time, in this command, we had last online -14d. This is literally the same thing as if you had provided this code snippet, only a lot shorter. The PSF datetime parameter class allows time-relative strings to be presented and it will parse them correctly into full datetime objects. So this makes it more convenient to give me all events from the last 7 days, things like that. Now this is nice if we already know about it. So let's go ahead and have now our own commands, our own modules. Let's say we create PS custom objects. Not everybody's a C# developer out there. We've got some custom things, and now we want it to pick up the name property and accept that instead. But if we run it, it has no way to bind it. It doesn't have any idea what to do with the object. What to do? First of all, we need to give it a name. If you give an object a name with the PS type name property, the property will not show up. Instead, it will show up as the type name. This is how we can name custom objects, which also makes them subject to things like format XML in order to style it globally for your module, or you can apply type extension XML to that name. So this allows you to benefit from these powerful technologies simply by adding that kind of line, PS type name to it. The rest will happen more by itself. Now, the PowerShell framework has a command called register PSF parameter class mapping that allows us to map this name and the property to the parameter class. So let's run this again. Right, picked up the right property. And what's more, if your module registers your output like that, your output objects, not only do your own commands understand it, but another module that may never have heard about your module, but uses the PowerShell framework, will still be able to understand your computer objects. Okay. This leads us to another nice command called invoke PSF command. You know, I'm pretty much sure everybody of you knows invoke command. This one is a bit more evil. Because what it does is it implements the PSF computer parameter class and can directly process it. Now again, private machine non-domain joined in what amounts to all purposes as a home network, untrusted. I can't really specify a remote session, but I can execute it against localhost at least. What happens here? PSF computer understands PS session objects. Invoke PSF command understands PSF computer, so whatever passes through here can be passed through here. If you specify a PowerShell session object, invoke PSF command will reuse it. In conclusion, all you need to do in order to be able to smoothly reuse sessions the user provides is have your computer name be PSF computer rather than string, and use invoke PSF command rather than invoke command. That's all you need to do in order to be able to smoothly reuse PowerShell sessions. Also, it picks up the difference on localhost. So if you have a list of computer names and one of them happens to be your localhost, which it detects by IP address, by your DNS host name, by your local net BIOS name, it will execute your local execution differently from the other, so you don't have any problems, for example, from not running elevated locally. Which is also why this current execution is used, because I didn't need to go through the WinRM interface. Not sure about that, Ben. Sorry. You'd have to test that. Probably not quite, because one of the other things it does in the background, if you give it a non-PS session object, it will create a PS session and maintain it for you, and after, by default, 15 minutes of not using it, discard it again. So if you do repeated invoke PSF command uses using a string name, on the first call, it will create a PS sessions, and on subsequent calls, it will reuse them, giving a huge performance boost on that without forcing you to manage your sessions, or force the user to manage sessions. It handles that for you. All right. With all this done, let's move on swiftly to the validation attributes. Complete change of focus here. I totally dislike certain validation attributes, specifically validate pattern and validate script, at least as they are in Windows PowerShell. In PowerShell Core, they're cool. In PowerShell Core, they actually understand you can specify custom error messages, but regular validate script is like totally nasty. So with PSFramework, you've got PSF validate script, and you can specify an error message. Let's run this. This is cool. This is not cool. But I did a get path does not exist, rather than this script block did not provide proper results. Please go and check it out. Now, this is cool, but if you've got a complex validation script block, this can totally ruin your parameter block if you've got like 10 lines of validate script. And if you need to use the same validate script on multiple instances, you need to maintain changes in every single instance. We don't do manual labor. It kind of violates my religion, so we don't do that. Instead, you can register a script, the validation script block, under a name, and call it by name, rather than a script block. Also, if it were working properly, the localization feature would also be available for localized error messages rather than just having one error message. So yeah. Only even numbers in German. So here the language selection worked properly, but number 2 is all right. Now, the same is true, actually even more true for validate pattern. Because let's be honest, there are very few people out there who can read regular expressions on site. And if anybody in the audience can read this by eyesight, I will be very impressed. Like, really impressed. Totally be awed by you, if you can handle that. Yeah, what that is actually the regular, no, it's IPv4, IPv6, and the legal DNS name. Yep. And this is, by the way, this regular expression is in the background used by the PSF computer class to validate strings. It took me a long time to build it, and I cannot guarantee it is 100% foolproof. It will, however, catch most of the things I've tried against it. One of the pain points, theoretically, is that illegal IP addresses are legal DNS names. So I can't prevent that, unfortunately. Okay. It totally works for foo, but we'll throw on a spacebar. So validate set. What can we do about validate set? I mean, validate set is working quite right, isn't it? Well, yes, but with PSF validate set, you also get the tab completion parameter, and that allows you to tie into the previously shown tab completion system. So let's take a look. We can still drink a pitcher of beer. It is still a legal value. Now it is no longer. Again, beware about the caching feature in this. They share the same caching feature and the same cooldown. And if you use conditionals in the script block, or if there actually is a legal change, it will not become allowed in the script block until the cache expires. But other than that, this allows you to fully finish the implementation on dynamic parameters for validate set, because this way you can also enforce that the custom tab completion is also the list of legal values. At the same time, if you do not use caching and you've got lengthy queries, you pay twice the query, because first for tab completion and then for the validation. So that's a bit of a danger on the performance end of things. All right. We need to decide when we execute PowerShell code what to do and at what location and what time. We have decision points in a script. For example, we might want to react different to specific PowerShell versions, or whether our command console is currently elevated or not. We've got a command for test piece of PowerShell that will validate most of the regular console environments, like the versions, the editions, operating system, what have you. All right. The other thing I am ambivalent about is the user experience of errors. Red code tells us basically it's broken. Most beginners will then not start reading that red error message. They will start Googling for the next solution, one that is not broken. So depending on your target audience, it might be a good idea actually to not throw red stuff at the screen, but instead write a nice, less alarming yellow warning message that tells the user, sorry, could not resolve computer name. That, however, if we just say, okay, we're not throwing exceptions, let's instead go with, warnings, all warnings. This is painful from a developer experience because now it's very hard to tell whether your command actually succeeded or not. So if I write code that is designed to be end-user facing, what I do is I implement opt-in exceptions. That is, by default, my commands will not throw red stuff at the screen, if I can help it. But if the developer tells it to enable exceptions, that's cool. It will throw exceptions, the developer can try catch it. This covers both bases. And in the original implementation, it was quite painful to implement. So we've got some tooling for this. Basically a command called stop PSFfunction. It tells the system, well, kill me, please kill me. I want to die. And if the user specified enable exception, well, guess what? It will throw in a terminating exception and the developer can try catch it. If it did not, it will write yellow stuff. Now, problem, if we use return in advanced functions, very few people actually know, it only ends the current block. So if we call return during begin, this command will not end. Instead, it will move on to process. So stop PSFfunction places a flag that test PSFfunction interrupt will recognize and will only then be true. So if you use stop PSFfunction at the beginning, this will be true and it will run return again. Same at the end. However, sometimes during process, when we're processing each item, maybe we only want to eliminate one execution and move on to the next item, unless we throw an exception. This is used using the continue statement, continue parameter, rather than the return statement. So let's see this in action before we theorize about this any longer. Let's tell it to die during the begin phase. It stopped, it did not process a single thing. It was told to die during begin. If we do this with enable exception, we got red stuff instead. And this we can now finally try catch. If you just run it without any parameter, it will complain about the number 2, but the rest is okay. If we enable exception, it will throw terminating exception on the 2, but the first one was processed all right. And the same is finally true during the end phase. But we never triggered the end phase exception because enable exception caused it to terminate in the process block. No. The other thing I keep seeing is support should process. So many pstheme delete should process, give me the result. So there's a test PSF should process that does the same thing. Now, rather than some obscure variable and a method call, we now have a command with parameter names. Nice enough, but why? I mean, this is still one line. It's a somewhat longer line even, so why should we use it? This we can mock during pester. And this means you can mock your code path depending on whether the user wanted to run what if or should confirm things, which means you can ensure in your tests that it did not actually change anything if it wasn't supposed to. I think this one is by now no longer mandatory. Let's see. Define the function and yep. Now it wanted prompting. Not a good idea to confirm that in the screen above. Anyway, that covers the should process thing. But let's take it to the latest and greatest features in all the flow control commands. let's take a look at how we used to handle things previously. And that is PSFramework should process doing nefarious deeds. Then we try to do something, and if it fails, which admittedly is somewhat predictable in this instance, we call stop PS function, or we throw something, or whatever. We do the error handling here. This works, but is quite a lot of text. It takes long to type. And it's so much repetitive. This try-catch block, the should process, everything is, it's okay, but it's a lot of overhead. So enter invoke PSF protected command, rolls it all into a single command. It will try to execute the script block you specify and handle the error handling when something breaks. In the way of calling stop PSF function behind the scenes. So let's run this. Oh, great. I still need to find a fix for this. Gods, thank you very much. All right. So far, exactly what we had before, and that it simply handles the error, writes what failed, logs a message, which we can now access with regularly. Okay. Going through fast for the rest. If we take a look at the current folder, we have a few items here. So it also introduces a replacement for export CLI XML called export PSF CLI XML. This is going to take a while. This is not going to take quite as long due to file system caching. And we now have the same export with export CLI XML is 830 kilobytes, 11 kilobytes for the PSF CLI XML. What this really does, it uses the PowerShell native serialization and then uses string compression. So the resulting data is pre-compressed. That's all there is to it. But it makes for faster exports and less disk impact rather than using the default path. The import PSF CLI XML can understand both versions. And for in-memory conversion, we can totally convert it into a string that can be pasted and copied into another console, and if convert from PSF CLI XML, be re-encoded into a PowerShell object. This latter is especially, it allows you to pass PowerShell objects, for example, to REST APIs, to and from. If you want to work with PowerShell functions, this is a handy way to pass through objects to an Azure function or AWS Lambda and have the function handle that. All right, this is the high-level view of most of the things I term a component that is more than a single command that play together. We've got a few more entertaining objects. Select PSF object. Select object is well known to all of us, but if we want to rename a property, let's say we want rather than length, we want to have size. We need a hash table like this. It's serviceable, it does the job, but it is nasty to read, especially when we start adding multiple properties like that. So instead, select PSF object, you can specify SQL style rename. Length as size, that's it. Of course, let's be honest, these numbers are not exactly management compatible. They're very technician oriented. So let's reformat it as a size in kilobytes with 2 positions after the dot and include the unit. Very convenient when it comes to CSV exports, at least in my opinion. So I've prepared a CSV file for demonstration purposes. Let's ingest it, it's a list of files, and sort it. Well, we've got 4 files, and as you can see, we sorted by length, but it's very obviously a string sort. String sort is, doable, but generally after we recover data from a CSV, we need to first convert the numbers back into being numbers before we can properly sort them. So we can typecast with the to operator. Now the sorting is correct. No, Ben, it cannot. However, there is a typecast type on my to-do list that will do this for you. We have that in DBA tools. I basically just need to migrate the data from there. Okay. Now, some of the other aspects I keep encountering is that people want to hide things from the user. For example, let's take a look at this. This is lots of information. We don't want everything to be shown by default. So let's grab everything, and in addition to that, pick the length property, convert it to long, and name it size. And then only show name and size by default. It still has all the properties. So if we now go ahead and use for table with wildcard, it will actually still show everything. But using the show property allows us to pick the default properties to display. Now, this is all nice from an object data handling, but I was very much in SQL mode at that point. You know, all these SQL kind of statements here. So I decided, all right, let's go full hog. Let's do a left join on another variable. First we need to pre-populate it. And what we're going to do now is we're going to pick the text property from the variable list where file length and length match. Okay. Moving on, I've got lots of fun providing for the run space ecosystem tools that are not really available by default. We've got good workload management. We've got POSH job module. We've got MAD multithreading, which, by the way, is awesome if you haven't looked at it. It does some very cool things. MAD multithreading is awesome for inline parallelization of a command, while POSH job is good for just pushing out workloads into background threads. Now, I'd like to provide some of the more arcane tooling, but one of them I recently showed in the community Power Hour, and that's the dynamic content object. What this is a tool that gives you access to the same variable in multiple run spaces. This does not literally add the variable, but you can define a variable that points at the same piece of memory. And this allows you, for example, by specifying a queue. You always need a name, but other than that, I define it as a queue that is run space safe. So now I can add data to it and later dequeue it. And the enqueue and dequeue do not have to happen on the same run space. So I could have some worker run spaces in the background that add data to it, and then retrieve it on the main run space or in other worker run spaces that are supposed to process the data. So let's go ahead. I'm going to start 5 run space jobs that access the dynamic content object here, and then we'll add 100 messages to it, but in a random time order, so the messages will be totally randomized. Thank you very much. And now we can, at our leisure, dequeue it, and in whatever random order, while it's being filled on background. All right. two more things to go before we are done today. We've got an object, and this. Where did I mess up? Yes, there did I mess up. We've got an object, and it has a name property and a numbers property that has multiple numbers in it. If you look at it from this perspective, if you try to convert this to CSV, all we get is a system.object brackets. Thank you very much. It exports CSV, flattens the data in a very ugly manner. So let's go with convert from PSF array first. And well, look at that. The numbers survived. What does this do? For each object that is passed to it, it will check for properties that are actually collections, that are a list of numbers that would not convert well, and force converts them with a string join, only the properties. And of course, we've got a join by, so we can totally instead join by with a separator of a choice. One warning ahead of time, this is not optimized for performance. If you don't care about performance because you're only exporting 100 datasets to CSV, it's totally cool. If you're exporting millions of datasets, the performance hit is going to be prohibitive. In that instance, you're better off using a custom select object. But for convenience exports, this is totally fine to use. It will work. Finally, I've spent days and days of work in all these projects. Weeks, really, months. I find it hard to calculate the time I spent on all my tools and toys here. And then I go out into the wild to the user. And the user comes back and tells me, it's broken. Fix it. Yeah. All right. What's broken? How is it broken? What happened? What did you do? The problem is, once our tools are outside of our hands, it's really, really, really hard to get good bug reports. There is no way the average user is even going to be aware of what we need. And he's a bit busy. He doesn't have much time. He's already angered that the thing's broke. So getting a good bug report is really, really hard. It's pain I've been suffering through for years now. And I'm sure all of you are in the same boat where that is concerned, because I can't imagine users are magically different over in New Zealand and Australia. So there's a command to fix this. New PSF support package. All you need to do is tell them, run this command as a zip file on your desktop, send me that zip file. And I'll know what to do. I'll be able to fix it. So let's see what happens when we do. By default, it places it on the desktop for the demo purposes. I'm going to throw it into the demo folder. And what this does, it gathers quite a bit of information and wraps it up as a zip file. So let's unzip it. And there is now this file. Again, we need that object. And what we get now is a data object with quite a bit of useful information. For example, we can see what modules the user had loaded at the time. We can also see all the messages that were written. Oh, we can see what PowerShell version the user has. Or what assemblies were imported. Of course, we also have this command history. So you might want to warn people that it might get more information that they're actually expecting. We get some information on the operating system itself. And this is my personal favorite, this will not work on ISE, it will only work in the PowerShell exe. We get a screenshot of his console. Furthermore, in instances where the user did not run code that properly adds the error exception objects to the messages, for example, he's using code that does not actually use the PS framework, you still have access to the original PS errors, which you can access usually using the $errors variable. So you get a full debug dump of every piece of information I can imagine the console can provide that can help you debug things. Let's just say it has significantly improved the error messages I get from users. All right, and that's it for the various tools. I'm not going to bother you with the license system or with the experimental features flag system or all the other things. There's a lot more details, a lot more tools on the entire thing. I have added a few additional tabs on various of the components we discussed today. And I have included links where I already have relevant levels of documentation, which in this instance is, there's a bit, but not much on the logging part yet. I'm working on that. There is a recording for this for my PowerShell Conference Asia presentation. Bad sound, but it covers, for example, how to implement your own logging provider or plugin. So if the logging part spoke to you, there's more data on that covered in that presentation. Yes, I'll make all of this available and post a link in the user group so you can access all the slides, all the presentation materials. If are there any questions, anything you really want to know right now?
Actually, Fred, one question right back from near the start. We're not going to break anything if we try and run write PS message and write verbose in the same function.
You're not going to break anything, you're only going to be doubling the message.
Yeah. Well, no, I mean, if you've got a mix of them and haven't changed them all, and yeah.
That's totally cool. Really, you're not going to be risking anything with that. There is no interaction on that level. What you also can do if you want to experiment with it without breaking your code is do this. Set alias, write verbose, write PSF message proxy. And suddenly you also write messages like that.
That's very handy.
No, there is no direct integration into SCCM. What you can do with SCCM is deploy registry keys to control the configuration system. You can also deploy configuration files. And yes, Ben, this is totally doable. And highly recommended, in case you're wondering.
Yeah, that was awesome. Thanks, Fred.
It's been a pleasure. Thank you for spending about 1.5 hours listening to me bragging about my toys.
I think I'm going to be using some of this stuff in the very immediate future.
If you've got any follow-up question, I'll definitely be happy to answer anything you can come up with. I hang out very frequently in the PowerShell community Slack and in the SQL Server community Slack. In both instances, ping me directly. I hang out there. I've got it open all the time, but I don't have the time to constantly monitor all this insane message traffic that's going on in both.
Yeah, I've got the bridge on the PowerShell Slack just on mute because I just can't.
Similar for me. It's such crazy message traffic. I just can't track it all. All right.
All right. Yeah, thanks again, Fred.
In
That
that
was
case,
awesome.
been a pleasure.
Yeah, if anyone's got any other questions, I guess fire them through on Twitter or Slack, unless you want to type them really, really quick now.
Yes. Be seeing you.
Awesome. Well, thanks, Fred, and thanks everyone else for tuning in tonight. I don't know the date for our next meeting offhand, but keep an eye on Twitter and Meetup and all that, and we'll get the message out soon. So thanks again, everyone, and we'll see you later.
Be seeing you.